Hi, my name is Tommy Upton, and today I'm going to be talking about lasers. Laser is actually an acronym that stands for Light Amplification by Stimulated Emission of Radiation. Lasers, in fact, are intense beams of light that don't dissipate over a given distance. So here's how lasers work. Lasers are dependent on the light that is emitted when an atom returns from an excited state back to its ground state. The way this happens is we put energy into atoms and they energize the atoms that cause them to go into this excited state. The excited state, however, is unstable for these atoms, which causes these atoms in return to go back to their ground state. When this happens, the energy emitted from the atom going from the excited state to the ground state we see in the form of a photon. The next step in the creation of a laser has to do with the photons. Once the excited atoms create photons, you see what is called photon emission. Photons like to be in the same state, so once one photon is emitted, it affects all the other photons around it, causing them to be emitted as well. This chain reaction is known as stimulated emission. So here's how it all comes together. Right here we have our energy input, and then we have our laser setup. The laser, it's a cylinder, and it'll have substance inside which has all these atoms. On one side of the laser you have a mirror with a hole in it which allows the laser beam to escape out. On the other side of the laser you just have a solid mirror. So this energy input, it puts sparks into these atoms like we talked about earlier. It energizes them, it excites these atoms, and once these atoms are excited, it emits the photons like we talked about. So these photons, the chain reaction occurs, and these photons start bouncing around inside of the tube. So these photons, they will reflect, some of them will reflect out of the tube, and they'll escape out of the side of the cylinder. But some of these photons line up parallel with these mirrors. These photons that line up parallel with these mirrors, they start bouncing around inside of the tube. When this happens, it creates a constant wavelength. Alright, so once you have this constant wavelength inside the laser, the next step in the process comes the creation of this laser beam. If the length of the cylinder is appropriate in relation to the wavelength, then these photons will bounce around and they'll create one standing wave. The hole at the end of this mirror will allow all those photons lined up together to exit out of the hole to escape into one intense beam of light that is one single wavelength. So here are some modern day applications of lasers. You have laser pointers, which can be found by teachers in classrooms and presentations, workplaces all around the world. You have barcode scanners, grocery stores, barcodes, the lasers there are used to pick up and scan items. Range finders, those can be used in golf, the military, all sorts of things. And then eye surgery. LASIK eye surgery is becoming a big deal now. People don't want to wear glasses or contacts, they go get LASIK eye surgery. The two applications that I'd like to focus on are the range finders and the LASIK eye surgery. So first, the rangefinder. The way a rangefinder works is the rangefinder emits laser beams at the push of a button. Those beams bounce off distant objects, and the rangefinder's high-speed clock measures the total time it took from when the beams left until the beams returned. Since we know how fast the beam was traveling, the speed of light, the unit can simply use the time measurement to calculate the distance it traveled, and then it displays this distance to the user through the lens. So again, those range finders, you can use them on golf, see how far away the hole is, or hunting, you can see how far away your target is. The next application I'd like to focus on is eye surgery. LASIK eye surgery is becoming increasingly popular in today's society, but most people don't really understand how lasers apply in this eye surgery. So the way lasers kind of come into the surgery is, first an eye surgeon uses either a mechanical surgical tool or most likely a laser to create a thin circular flap in the cornea. The surgeon then folds back this flap to access the cornea under the tissue. And once he does this, he removes some of the corneal tissue using another laser. This highly specialized laser uses a cool ultraviolet light beam to remove microscopic amounts of tissue from the cornea to reshape it so it more accurately focuses light on the retina for improved vision. For nearsighted people, the goal is to flatten the cornea. With far-sighted people, a steeper cornea is what is used to fix. Lasers also can correct astigmatism. By smoothing an irregular cornea into a more normal shape, it cures this disease. Thank you for your time. I hope you learned a lot about lasers and understand a little bit about the applications of lasers and how they work.